And that brings us to a problem with time series regression analysis, and that's called autocorrelation. So the problem with autocorrelation is we don't have a problem with biased coefficient estimates. Our coefficient estimate is unbiased, and our parameter estimates are consistent, meaning that the larger the sample size, the closer they are to the real value. But our standard errors are going to be biased. That means the t-statistics are going to be too high. So we might be concluding that the independent variable affects the dependent variable when in fact it actually does not. Okay, so we can detect that with a runs test, and that's introduced in section 12.8 of the textbook, or a Durbin-Watson test, and that's introduced in 13.8. We can do a runs test in Excel pretty easily, but we're going to need SPSS to do a Durbin-Watson test easily. We can do it in Excel, but we'd have to construct the test ourselves. Okay, so the runs test, you save the residuals and then plot them over time. And then you count the number of sign reversals in the residuals. So some are going to be positive, some are going to be negative, and you count the number of times that the residuals crosses the zero axis, or the intercept for the vertical axis. And if that number, so you count those up, and if the pattern of residuals is random, then the sign changes will be about 1/2 of the number of observations that you have. But if the sign changes are less than 1/2, then that's known as positive autocorrelation, and that's the type that we usually get with time series data. If the sign changes are greater than half, then we have negative autocorrelation, and that's rare. So we're just going to worry about this positive autocorrelation problem. So here's what it looks like, and this is output from SPSS. So here we have the unstandardized residuals on the vertical axis, and right here is 0. Okay, so the residuals are plotted, and then they're connected. Those dots are connected, and you can count the number of times that they cross that zero axis. So 1, 2, 3, 4. And we've got 0 over 60. We've got 67, it turns out, time series observations. So 4 is less than 33.5. So we do have positive autocorrelation. The Durbin-Watson test is another test, maybe a more rigorous test than the runs test, that is constructed with the residuals. So the Durbin-Watson statistic is equal to a numerator and a denominator. In the denominator, we take all of the residuals and we square those. And in the numerator, we add up, and then we square those and we add those up for all of the observations. In the numerator, we take a residual in time t. I guess that's a mistake there. Let's see. There we go. So you take the residual in time t and subtract from it the residual in the preceding time period. So if t is 12, e of t minus 1 is time period 11. So you subtract, you get the difference in residuals, and you square those. And since it's a difference, we have one less number in the numerator, than the denominator. So we add those up from t equals 2 to n. So if that Durbin-Watson statistic is less than 2, then that indicates we have positive autocorrelation. If it's equal to 2, we have no autocorrelation. If it's greater than 2, then we have negative autocorrelation.